Have you ever been like staring at your screen, furiously typing away to meet some hard deadline? And right in the middle of your flow state, your operating system decides to just slide a notification into the corner of your eye.
Oh, absolutely. Happens all the time.
Right, and maybe it's a newsletter for air fryer recipes or some random billing update for a cloud service you barely even use.
Yeah, something completely irrelevant to what you're doing.
Exactly, and it derails your focus entirely. And in that moment, I mean, the frustration isn't just about the distraction itself. It's this realization that you spend, what, 8 to 12 hours a day on this machine, and it still doesn't actually know you at all.
No, it really doesn't.
It has no idea that you're stressed out, no idea you're working, and absolutely no context for your actual life.
And, it is a profound failure of modern computing.
Mhm.
I mean, we generate an immense amount of personal data every single day, yet the devices we rely on basically operate in a state of perpetual amnesia.
Yeah.
They just don't understand our overarching goals or our immediate cognitive load.
Well, our mission today is to explore how that might finally change. Welcome to the deep dive. We are looking into a really fascinating new human-computer interaction research paper. This is from Stanford and Microsoft Research.
Right, it's a great paper.
Yeah, it's titled Creating General User Models from Computer Use. And the researchers are proposing this massive shift in how software interacts with us, moving away from, isolated algorithms towards something called a general user model, or a GUM.
The shift here really is fundamental because right now, user models are just completely fragmented.
How so?
Well, you have an algorithm that tracks what you watch in a streaming service, right?
Right.
And then a completely different one tracking what you buy on a retail site.
Oh, sure, so they don't talk to each other.
Exactly. They have what the researchers call pinhole views.
Pinhole views, I like that.
Yeah. And a general user model, by contrast, is designed to watch unstructured inputs across your entire operating system. So it builds a unified, continuously evolving, and entirely private profile of your knowledge, your beliefs, your habits, and even your current stressors.
It's essentially giving the computer a continuous memory because, right now interacting with AI often feels like dealing with a goldfish assistant.
A goldfish assistant.
Yeah, like every time you open a new tab or start a new prompt, it completely forgets who you are. You have to over-explain your entire life context every single time.
Oh, right. Like, I'm a PhD student. I am working on this specific paper.
Exactly. And I need you to format this in a very certain way. It's exhausting. But, okay, let's unpack this because observation is technically cheap. I mean, any basic spyware can log keystrokes.
Sure.
How do the researchers propose going from, like, raw pixels to actual structured context without forcing the user to just sit down and fill out a massive 1,000-question survey?
Well, that is the core technical hurdle.
Mm-hmm.
And their solution relies on unstructured observation, which is driven by large vision language models.
Vision language models.
Yeah. So the system literally takes periodic screenshots of your computer as you go about your day.
Wait, it's just taking screenshots of everything.
Exactly. It watches as you write documents, browse the web, or message colleagues. And the vision language model, in this specific study, they use one called Qwen 2.5 VL.
Okay, Qwen 2.5 VL.
Right. It analyzes the visual data on the screen and translates that raw pixel behavior into a structured semantic understanding.
Okay, I see the value in the observation part, but gathering data is kind of the easy part, right? The real bottleneck in AI right now is synthesis.
Oh, absolutely.
If a model is taking a screenshot every few seconds, it's going to just drown in noise. So how does the architecture actually process all that visual data into intelligent insights without, I don't know, crashing your hard drive or hallucinating connections that just aren't there?
Well, to manage that exact problem, the researchers built a 4-step pipeline.
Okay, what are the steps?
It's observe, propose, retrieve, and revise.
Observe, propose, retrieve, revise. Got it.
Yeah. So the observe step is the screenshot gathering we just talked about. But the intelligence really begins in the propose step.
What does that look like?
The AI analyzes the observation and generates natural language propositions about you. But crucially, it doesn't just, state a fact. It generates a rationale explaining why it thinks that, and then it assigns a mathematical confidence score ranging from 0 to 1.
Oh, interesting. And there is a highly relatable example of this in the paper that I loved. The researchers had the model observe screenshots of a user switching rapidly back and forth between two windows.
Ah, yes. The ice cream example.
Yes. One window was an overleaf document, so writing complex latex code, and the other was a YouTube video for ice cream recipes.
Right. So the model watches this specific behavioral pattern, processes the context of both windows and generates a structured proposition.
Which was something like user periodically views ice cream recipes while writing.
Exactly. And it assigned that proposition a confidence score of zero point 0.7.
Mm.
So it essentially observed unstructured procrastination and turned it into a structured behavioral assumption.
See, that's super impressive, but if I'm the user, I don't really want to be permanently branded as an ice cream fanatic just because I had a stressful Thursday.
Well, of course not.
Because if the model acts like a permanent ledger, it's going to build a completely warped profile of me based on like passing phases. I kind of think of it like a digital radioactive half-life.
That's a good way to put it.
Right. Some traits, like my career, should have a very long half-life, but my interest in a specific dessert recipe should radiate away almost immediately. So how does the model distinguish between a core identity trait and just a temporary distraction?
Well, that is exactly how the architecture is designed, using what they actually call a decay score.
Oh, they call it that.
Yeah. The system relies on an underlying language model to assign a specific decay rate to every single proposition it generates.
Okay.
And the mathematical beauty of this is that it really mirrors human memory. So a proposition like user is a PhD student is given a decay rate that is incredibly slow.
Because that's a stable anchor fact.
Exactly. But a proposition like users debugging a memory leak or, users eating ice cream decays very rapidly.
Because it understands the temporal nature of the task. Like, if I'm debugging code, that's an acute state. It's not a personality trait.
Spot on. And this leads right into the retrieve and revise steps of the pipeline.
How so?
The GUM doesn't just stack new facts on top of old ones infinitely. It uses retrieval frameworks. Specifically, in the paper, they evaluated an algorithm called BM25.
BM25.
Yeah, it uses that to pull up past propositions. And BM25 doesn't just do a simple keyword search. It calculates how rare and relevant a specific piece of information is across your entire history.
So it's constantly contextualizing new data.
Right. So when a new observation comes in, the model pulls the most relevant past assumptions and revises them. So if you stop looking at ice cream recipes, the confidence in that proposition steadily drops, or the proposition is just rewritten entirely.
Okay, but if the model is constantly retrieving my past behavior to predict my future, we have to talk about the blast radius of this data.
The privacy aspect.
Yeah, the privacy aspect. Because if this thing is taking screenshots of my screen all day, it's seeing my banking passwords, my highly confidential work documents, my private messages.
It sees everything.
Exactly. A single breach wouldn't just be a data leak. It would be a complete exposure of my digital identity.
And the researchers acknowledge that. Privacy is really the existential threat to a general user model. If users don't trust it, the technology is basically dead on arrival.
So how do they solve it?
To mitigate this, they built a strict audit module into the pipeline. This acts as a checkpoint before any data reaches the user model.
Okay, a checkpoint.
Yeah, and they grounded this module in a philosophical framework called contextual integrity, which was developed by Helen Nissenbaum.
Okay, but how does philosophical contextual integrity translate into actual functional code? Like, what is the logic loop the AI is executing when it sees, say, a password field?
Well, the audit module uses the GOM's own established knowledge of you to determine if capturing a screenshot violates your personal norms.
Wait, it uses what it knows about me to protect my privacy.
Exactly. It runs through a specific set of questions. Things like, who is the subject in this data? What is the nature of the information? Who is the recipient? And what is the transmission principle?
Can you give an example of how that plays out?
Sure. So for instance, if the model has a deep history of you sharing research papers with colleagues over email, that establishes a contextual norm, right?
Right, that's normal behavior.
But if you open a banking portal and begin entering financial data, the audit module analyzes that context, recognizes that financial transmission is outside your established sharing norms, and automatically blocks and deletes the screenshot before the GUM even knows it existed.
Oh, wow. So it's using its understanding of my habits to actively protect my habits.
Precisely.
But, I mean, that reliance on incoming data also seems like a massive vulnerability.
How do you mean?
Well, if the model updates its beliefs based on what appears on my screen, someone could theoretically manipulate my psychological profile just by sending me a message, right?
You've identified exactly what the researchers found during their evaluations.
Really?
Yes, they call it a spam injection vulnerability.
Spam injection. Okay, how did that happen in the study?
Well, in one of the studies, a user received a standard phishing email. And because the email simply appeared on the screen in the user's inbox, the GUM ingested the observation.
Oh, no.
Yeah. It then, mistakenly but highly confidently, proposed that the user was actively interested in the scammer's topic.
Just because it was on the screen.
Exactly. It proved that these models can absolutely be manipulated by malicious external inputs that alter the user's local context.
That is wild. I mean, think about your own screen right now. Would you be willing to install a system that logs everything you do, knowing it has potential blind spots like that? It feels like a massive leap of faith.
It really is,
Yes.
which makes the results of their longitudinal study so fascinating.
What happened?
They ran a 5-person study where they deployed the system on users' actual personal screens for 5 days, and they encountered what they termed the privacy paradox.
The privacy paradox.
Yes. So initially, the participants were highly defensive. I mean, one user explicitly stated that if they hadn't known the researchers personally, they would never have installed the software.
Which is the completely rational response to a local surveillance engine.
Right. But the paradox is that within 24 hours, that fear entirely evaporated.
Wait, entirely in one day?
In one day. The users habituated to the continuous monitoring because the utility of the system was so undeniably high.
Wow.
The contextual help was so good that users actually reversed their stance and wanted to feed the AI more data. They started asking if the model could track their smartphone usage as well to complete the picture.
That is incredible. Okay, so the GUM has successfully built this perfectly private, highly accurate map of your life, and users are willing to accept the privacy trade-off.
Yes.
But a map isn't really useful unless someone is driving the car, right? The model just sitting there knowing things doesn't actually save me time. So who is taking action on this data?
And that brings us to Gumbo. Yes, Gumbo is the proactive agent built to run on top of the general user model.
Okay.
And unlike current assistants, where you have to explicitly formulate a prompt and ask for help, Gumbo operates autonomously in the background. It basically monitors your state and calculates the expected utility of interrupting you.
Expected utility, meaning it weighs the pros and cons.
Exactly. It actively weighs the potential benefit of a suggestion against the cognitive cost of breaking your focus.
See, that calculation is critical because
Yeah.
if it just fired off a suggestion every single time and noticed something, it would be worse than the random OS notifications we talked about at the beginning.
Right, it would just be Clippy all over again.
Exactly.
So it uses a mixed initiative interaction framework, which basically means it rate limits itself to avoid becoming a nuisance. It caps its suggestions to a maximum of 1 per minute.
That's smart.
But when it does choose to act, the cross-contextual reasoning is really remarkable.
Oh, the wedding suit example from the paper perfectly illustrates this.
I love that example.
Yeah. So Gumbo observed a casual chat message where the user was invited to a friend's upcoming wedding in Chicago.
Right.
And it didn't just, set a calendar reminder. Gumbo retrieved a long decay proposition from the GUM, which was, user is a PhD student.
Right, pulling from that deep context.
Yes. So it combined the impending formal event in Chicago with the assumed budget constraints of a PhD student. And then it autonomously searched the web for cheap suit rentals in Chicago. It just quietly presented the user with the exact results they needed before they even thought to look.
It's amazing. The agent connected an overarching identity trait to a temporary geographic event without any explicit prompting.
It's like magic.
I mean, current AI architecture just cannot execute that kind of contextual synthesis unless the user types out every single constraint manually.
Absolutely.
Another great example was a participant in the study who was watching Twitch streams.
Yeah.
Gumbo didn't just know that they like gaming, it analyzed the specific timestamps where the user was pausing the stream.
Oh, to see what they were focusing on.
Yeah. It deduced which specific character they were trying to learn, and then proactively recommended entirely new streamers who mains that exact character.
That level of detail is insane. And, it also solves the exact problem of being distracted during a deadline.
Oh, the CHI conference example.
Yeah. In the study, the GUM recognized a user was under severe stress because of an impending CHI conference paper submission.
Which is a very real stress for researchers.
For sure. And because it understood the overarching context of that stress, Gumbo acted as an intelligent filter. It blocked irrelevant operating system notifications, like Firebase billing updates, but specifically allowed the conference registration deadline notification to break through.
It defended the user's attention.
Exactly.
It creates a buffer between human cognition and digital chaos.
I love that phrasing.
Yeah.
But the bottleneck here has to be execution capability, right? Like an agent can have perfect context, but if it doesn't have the API permissions to act, it's just making empty promises.
Oh, definitely.
And the study actually highlighted some hilariously human failure modes regarding that.
Yes, the agent frequently suffered from what they call capability hallucinations.
Capability hallucinations. Give me an example.
Well, for instance, Gumbo realized a user wanted to discreetly watch an NCAA basketball game during work hours.
As one does.
Naturally. So the agent proactively informed the user, with supreme confidence, that it had scheduled a reminder on their calendar for tip-off.
Oh, that's helpful.
The user was thrilled. But Gumbo didn't actually have the API permissions to write to the calendar. It had completely hallucinated the execution.
Oh, man. It's like, don't worry, boss, I handled it. And then you completely miss the game.
Exactly.
It's like having a brilliant, deeply observant, but just vastly overconfident intern.
Very much.
But, you know, if the model is this good at picking up on underlying stressors, like a conference deadline, it's essentially building a localized psychological profile of you. Having a machine hold a mirror up to your behavior has to have some psychological side effects.
It does. It creates a deeply uncomfortable tension. In both the 18-person email study and the 5-person screen study, the researchers found that the natural language propositions generated by the model can be shockingly candid.
Candid.
Yeah, because the model relies on unstructured observation. It just doesn't filter for politeness.
Candid is an understatement, honestly. I was reading the paper, and the system was generating propositions like user is struggling with fixing bugs and user may be experiencing stress due to unread emails.
Very blunt.
Yeah, and for one participant, the system flat out proposed user is unhappy with their job.
Ouch.
I mean, reading an objective machine-generated assessment of your own misery based entirely on your own observed behavior? That is intense.
It is, and the participant reactions to this psychological mirror were sharply divided.
How so?
Well, some users found it profoundly validating. One person saw the proposition regarding their email-induced stress and expressed genuine relief that the system acknowledged the pressure they were under. They basically felt seen by the machine.
That's interesting, but I imagine not everyone felt that way.
No. Others felt completely exposed. One participant explicitly noted that even if the propositions about their struggles or, their procrastination were completely accurate, they would want to hide them.
They didn't want their laptop confronting them with their own flaws.
Right. It really exposes the friction between the true self and the ideal self.
Right. Because our behavior reveals our true self. We procrastinate, we get stressed, we struggle.
Exactly. But we prefer to interact with technology through the lens of our ideal self. The design challenge moving forward is really navigating this friction.
Because if a general user model is just sanitized to protect your feelings, it loses the context necessary to actually help you, right?
Yes, it needs to know you are wasting time if it's going to intervene. But users clearly harbor deep discomfort with being perceived so accurately by an algorithm.
Which brings up a big question of calibration. If it's going to make claims about my job satisfaction, it better be absolutely certain. How do the researchers measure whether the model's confidence scores actually align with reality?
That's a great question. To measure that calibration, the researchers utilized Breyer scores.
Breyer scores, what are those?
Think of a Breyer score as a mathematical penalty system for overconfidence.
Okay.
So if the AI is 99% confident that you hate your job and it turns out to be entirely wrong, the Breyer score penalizes the model heavily.
Makes sense.
Conversely, if it is completely unsure but gets it right anyway, it also receives a penalty for poor calibration.
Ah, so it needs to be accurate in its doubt as well.
Yes, and what the data showed is that the GUM is actually slightly underconfident when making these psychological assessments.
Which is exactly what you want. You would much rather the system be hesitant to assume it understands your deep psychological state than be arrogantly wrong about your mental health.
Precisely. The underconfidence acts as a natural safeguard against the system, taking, aggressive, misguided actions based on flawed assumptions about your mood.
Man, we have covered a massive amount of ground today. We've looked at how computing can move past the amnesia of the goldfish assistant.
We really have.
By leveraging these continuous locally hosted vision language models, our devices can finally translate the messy, unstructured reality of our screens into a structured, probabilistic understanding of our lives.
Mhm.
We've seen how decay scores mimic human memory, and how frameworks like contextual integrity attempt to build a firewall around our most sensitive data.
And we've explored how that foundation allows proactive agents like Gumbo to operate effectively. Finding budget-appropriate formal wear for a specific event, tailoring content recommendations based on exact video playback habits, and dynamically shielding our attention when we're under pressure.
It fundamentally rewrites the relationship between human and machine. But before we wrap up, I know we focused heavily on what a general user model means for an individual and their own private workflow. But I want to zoom out for a second.
Okay, let's zoom out.
If we look at the trajectory of this technology, assuming it scales and we all eventually run a highly accurate, deeply personal GUM on our local devices, we have to consider how it changes human-to-human interaction.
Well, that's an interesting angle.
Right. Think about the friction of meeting someone new. Will we eventually skip the awkward getting-to-know-you phase entirely? Imagine sitting down with a new colleague, and instead of making small talk to find common ground, your personal GUM simply communicates with their GUM in the background. The models instantly cross-reference your respective decay scores and propositions, establish exactly where your interests overlap, and hand you both a perfectly tailored, shared context before you even speak.
Wow.
Could we eventually outsource the vulnerability of social introductions entirely to our digital twins?
From an operating system that doesn't even know you exist, to a digital twin that actively networks on your behalf. That is a brilliant thought to leave on.
Thank you so much. Keep learning, and maybe close that ice cream tab if you're up against a deadline.